Hey guys, in this video, I'm going to go over all the different decorator nodes that you have access to in NodeCanvas, how to use them, and some basic examples. So I have a basic setup where I have an enemy character here, I have a player character here, I have some patrol points, and I have a behavior tree owner on my enemy. Now, the behavior tree owner has a few actions that I've already set up. So this one, he will go to the center of the game scene, and I've just set him to set his material so that it's visually clear to us what's going on. Patrol points, so he's going to patrol between these green points here. Seek player, so he's going to try to get to the player. And flee from player, he's going to try to get away from the player. And these are all set up basically with these action tasks. So let's have a look at the base logic. So we're using a sequencer. So what we're going to do first is go to the center of the game scene. Then he's going to patrol points. So he'll patrol 1 point. Then he will seek the player. Then after he completes that, he's going to flee from the player, and then he's going to go back to the beginning. So he goes to the center, he goes to a patrol point, he's seeking the player. So he has this little threshold here. He reaches the player, he flees from the player, and then he cycles around. So that's our basic behavior. And what we're going to do is we're going to enhance this behavior by using decorators. All right, so the first decorator that I want to go through is the repeat decorator. Now, in order to add a decorator to the node, there are two ways you can do it. One is you can press spacebar or right click and search for decorators. You see here, they're all here. I'll grab the repeat node. And then I can link that up by dragging like that, removing this, and move it into here. But there's actually a more optimal way. You can simply right-click, decorate, and then choose one here. And that's going to do those extra steps for us automatically. All right, so now we have our repeat decorator. So what we're trying to do is we're going to repeat the patrol so that he's going to do multiple points before he moves on to seeking the player. And it's as simple as adding, let's say, 3 points here. So repeat times 3. Now you see here you have a repeater mode where you can choose repeat until or repeat forever. So repeat times, he's going to repeat 3 times. Repeat until, it's going to repeat until this succeeds. Or repeat forever, he's just going to keep doing this forever with no limit. In this case, we're just going to do repeat 3 times. So now when I play, he goes to center, and now he goes 1, and you can see it count up here, iteration 2, iteration 3. He finishes that, and now he seeks the player. So that one is pretty straightforward. So let's have a look at another one. So I don't actually want him to seek the player unless he's within a certain range of the player. And so for this, we can use a condition decorator. So I'm going to right-click, decorate, decorators, conditional. All right, and now inside here, we can add as many condition tasks as we want. So I click add condition task, and in this case, I want to check the distance. So check target within distance, hook it up to my player who's in my graph variables, and I want to check if it's less than, actually I have a variable for this as well. So I'm going to use the graph, seek threshold. So if the distance is less than the seek threshold, then I'm going to play this. And we can do the same for the flee. Now what I can do is I can actually just go here and I can right click, copy, and then when I assign the condition task, I can just paste, and that's a lot easier. And I just change that to be the flee threshold. All right, so let's play. So I'm going to move my player closer to him. And you see he's doing the patrol. He finishes the patrol, and now he's seeking me because the distance was less. And now he's fleeing. But if I come over here, let him finish his patrol, he's not close enough to me. So he's not entering the seek threshold, nor is he doing the flee. Now let's say in our sequence, we want him to go to the center, patrol 3 times, and then wait until the player is within distance. And while he's waiting, do nothing. Well, in that case, I can use the wait until decorator. So right click, wait until. And what I will do here actually is I will just copy this condition. So right click, copy, and then just paste that like that. Delete this. And now what you'll see, move to center, patrol. Now you see he's waiting until his distance is within the threshold. I move here, now he's going to look for me, and then he exits out like that. All right, so let's have a look at the next set of decorators: limit, cooldown, and timeout. So for example, if I want to limit the amount of time something can run, I can simply use the limit decorator like this, and that's going to say it can only run a max of one time. So for example here, we only want to go to the center of the game scene once. Here, increase count policy on success or failure. So whether it succeeded this task or not, it will increase. So if we only wanted it to do it on success, we just change it to success. And the status that will be returned when the max times have been reached can either be optional, failure, or success. And that's going to depend on what your composite is expecting. In this case, we're going to leave it on optional. So that's only ever going to run once. After flee has finished, it will never run that again. All right, using the cooldown decorator, we can very easily add a cooldown to any of our branches. So for example here, I'm going to add a cooldown here of, let's say, 10 seconds. And so if 10 seconds have not elapsed since the last time this has run, then it's not going to check this again. So what's going to happen is it's going to go through all of this, and then the first time it goes into here, it's going to start that cooldown. It's going to wait until we're within the distance. It's going to seek us. Then it's going to do the flee, go back through here, and if it gets here and 10 seconds have not elapsed since this started, then it's not going to try that again. It's going to skip over that. All right, and lastly, our timeout. So we're going to add a timeout to the flee. So I'll just drag that there, put that there. So here, if we're within the distance of the flee threshold, then we're going to start this timeout, and we're going to time out after, let's say, 3 seconds. And what that means is that if the enemy does not flee the player within 3 seconds, it's just going to return our timeout status here of failure. You can change that, but in this case, failure is perfectly fine. Okay, I'm just going to reduce the repeat time to 2, just so it's a bit faster. And I'm actually just going to increase my cooldown to 15, just so we can see this a bit clearer. And let's make the timeout here maybe 4. All right, and let's play and see what happens. Okay, so the first thing is he's doing the move to center. When he finishes that, you see here, the limit has been set to 1 out of 1. Great. Now he's in the patrol sequence. He has done that 2 times. Now he's waiting to be within the distance of the player. So we move the player into distance. Okay. And now you see that has been set to be cooling. So that's now cooling down. And that's going to show us visually on the graph how long that cooldown has to go, which is very convenient. Now he's doing the fleeing from the player. And you see if I stay within that range, after the cooldown, he exits that because it's timed out. And now he's going into the patrol again. 1, 2. And what you see is that the cooldown was still active on the seek branch. And so he didn't go into the seek branch. He actually went into the flee branch, but he wasn't close enough. So he exited and he went straight into the patrol again. And now the cooldown has finished. So he's going to wait for the player to come into distance again, and everything's going to work. And as you've noticed, he's never going back to the center of the game scene because we have the limit decorator put onto there. Okay, so let's restructure the tree so I can show some other of the decorators and how they're useful. So we're going to add a selector here. Then I'm going to take my patrol. I'm going to put it over here. Then I'm going to take these 2. I'm actually going to get rid of this one. We don't need this one. That's the go-to center of the game scene. And I'm going to have my sequence like this. I'm going to set this one to be the start. So what we have here is a sequence where we're going to try to go to the player, then we're going to flee from the player. And if this fails, then we're just going to patrol. So let's move our cooldown into here. So now we have a cooldown. Let's just make that cooldown maybe 10 seconds. And that's going to fail because it's a selector. If this fails, it's just going to patrol. Okay, and let's make a timeout for the seek as well, like that. Okay, so now it's going to check if it can do this, if it's cooled down or not. Then it's going to try to seek the player, and if that fails, it's just going to patrol. Or if it fails to flee from the player, it's just going to patrol. And that's going to include whether the time it timed out or the condition failed. All right, and I actually want to replace that wait until. So I'm going to replace it with a conditional. And you see, when I replace it like that, it actually keeps the condition inside. So that's really convenient. So again, if I change it to wait until, you see it retains that condition. Replace, conditional, there we go. So now it's not going to block our execution. And what I actually want to do is I want to have another behavior over here, and this is going to be if my distance is less than 8 when I enter here, I want to log some text. So drag out action, debug log, I can see you, and we'll connect that up like that. Now, the problem right now is that because the sequence is going to go through, and if it fails that condition, then it's just going to mark that as failed and just go to patrol. But I want this to be optional. And so what I can actually do is I can use the optional decorator. So if I look in here, I have optional, I have succeed, and I have fail. And all three of these will force that status to go through. So for example, I could mark this as success. So it's basically saying, no matter what comes out of this, I want my composite to consider this a success, which means that when it comes through here with the selector, it's not on cooldown, it goes through here, the distance is greater than 8, it's not going to run this, but it will return success and move on to the next node. So let's have a look at that. All right, so you see here, it checked this, which failed, but it marked it as a success. Then it moved on to check if I was within the seek threshold, which I wasn't. So now if I move over here, wait for him to finish his patrol. So now, he did not log this text because it failed, but he was within the seek threshold, so he moved on to do that. Okay, now this time, I'm going to stay close to him. Cooldown finished, he logged, I can see you, and then he moved to the seek, and then to the flee. In this example, using optional or succeed will not actually change the behavior. That's because our sequencer is just going to go through these and return as soon as a child returns failure. The optional is not going to return failure. So whether it succeeds or is optional will not matter in this case. However, if I were to change this to be a selector instead, like this, if this is a succeed, and I'm just going to remove this cooldown for now. So now if we play, you see this returned as success, and it's going to be stuck on this, and it's not going to do anything else because this, regardless of this condition, is always going to run that. And when I get close to him, he's going to log it, and he's going to do his behavior, but we've blocked our entire behavior tree. Whereas if I change that to optional, now he's going to select properly which one is appropriate. He's running it properly, but he's not blocking our behavior. So let's just set that back to be a sequencer. Okay, so now let's have a look at our monitor decorator. So our monitor decorator is going to monitor the decorated child and execute an action when it finds the return status. So here, for example, it's looking for an on failure. So let's say I attach it here. So if the distance is less than 8 to the player, then on failure, I'm going to log, I can't see you, like that. Now here, it's going to return the original decorated child status, which in this case would be whatever this returns as, which doesn't matter because we're overriding it with our optional return here. So let's have a play and see what that does. So there, he actually logs, I can't see you, and he moves on. I can't see you, moves on. Now I'm going to get close to him. I can see you. And then he tries to find me. So I can also change that to monitor on success instead if I want to. So for example here, if he successfully seeks the player rather than being timed out, I got you, you just log that. And I can also add one for failure. So actually what I can do is I can copy paste that, connect it up. Okay, so actually what I want to do is I want to add that on failure to the timeout. So I move that down. So this is going to say on the timeout failure, I timed out. Okay, so he's going to try to get me. I'm going to escape him. And he says, I timed out. He can see me. He runs at me and he says, I got you. All right, so let's have a look at the merge decorator. So let's say, for example, when he patrols, I want him to randomly choose between two sets of patrol points. So I have these green ones here, and I'll copy them, patrol points 2. I'll copy paste this, create a new list, call that patrol points 2, expose it, public. Okay, so then here, I want it to use these 3 patrol points, delete these ones. Okay, and let's move these patrol points into here. Okay, great. And I'll make it a selector, make it a random selector. So it's going to randomly choose between one of these, and it's going to go, in this case, for the first patrol points, it's going to do it twice. But for the second one, it's only going to go to 1 because we don't have the repeat decorator. However, what you'll see is that we're assigning that patrol material and the exit range display twice, which is really not ideal. We have to copy paste this, and if we have a lot of nodes, it can get really out of hand. And so what I'll do is I'll copy this, move it here. I'll delete the random patrol like that. Then I'll go into here and delete everything except the random patrol. So now this is only going to do random patrol, same as this. Then I'll create a sequencer for here, a sequencer for here. And that sequencer can happen above that, actually, like that. Because we only want to patrol twice. We don't need to set the materials and stuff twice. Okay. Then what I can do is I can put that in there and put that in there and then move that into here like that. So now I don't have to copy it. It's using our merge decorator to do the same logic, which here is just sets materials. Now, one thing to remember is that our sequencer is going to execute from left to right, and it's not here from the connection, but from the placement of this node itself. And so what will happen here is that although this will work correctly, because this node is to the left of this node is to the right of this node. And so the material will not actually be set correctly. But what we can do is we can use our merge node to fix that. So I move that over there. And now this merge node is to the left, so that's correct. And this merge node is to the left, so that looks good. And I'll create one more merge node just in there like that. And now this should work perfectly fine. So here you can see, regardless of the points that he chooses, he will always go down this route. So he runs away, he chooses this one. So he's choosing these nodes, and he runs that material change, no problem, just before he does his actual patrol. And the same for when he does the patrol of these points instead. So let's have a look at the iterate and the override agent nodes. So we're going to use these in combination. So I've made a list of mini enemies over here. They're basically a copy of our enemy, but without the behavior tree, just with a nav mesh. and I'm going to add them here. So what I'm going to do is I'm going to go target list, graph, create new, and create a new for the current element and create a new for the current index. Now in my graph, I can just call this mini enemies, current mini enemy, and current mini enemy index. There we go. And what I'll make sure to do is change the type here to be a list of game objects, like that. And same with the current mini enemy. Good, and the index obviously is just an integer. Okay, and I'm just going to expose these public. Actually, this one, these two don't need to be exposed public because they're just going to be used by the iterator. But here, my mini enemies, just dragging it there. So I have all 5 of them in there. Nice. All right, and so for now, let's just make a sequencer. Set this one to be start. And for each of these, I'm going to do an action. And I'm going to log, and I can grab the current mini enemy. So it's just going to log the current mini enemy. Okay, there we go. 1, 2, 3, 4, 5. It has logged the mini enemies. Because our log takes 1 second, it's logged them every second. And you can see that going through the indices like that. 0, 1, 2, 3, 4, 5 elements, so 0 to 4 for our indices. So what I'm actually going to do is I'm going to make them all seek the player. So I'll grab the seek here, and I'll just remove the stuff we don't need. We just want to seek the player, like that. Okay, so now if I do this, what's happening is I myself am going to seek the player for each enemy. But I don't want that. Rather, I want every enemy to seek the player. So let's use our override agent. So we go into there, and our new agent is going to be our current mini enemy. And I'll move that into there, seek player. And let's see what happens here. So when I play, they will all go one at a time and seek the player. And you see they're all using the same parameters that our main enemy has. They know where the player is because it's basically just replacing what this graph is driving. And we can use the override to set ourselves back to what we were before. So I'm going to add this to our tree here. So I'm going to set that as the start and add it in here. And I'm just going to disable this one. So right click, disable. So he's going to seek the player. Then when he's finished seeking the player, all the enemies are going to seek him one at a time. So he's going to do the patrol. He's not within range. He is now within range. He's finished seeking me. And now all of these guys are going to seek me using our iterator and our override agent. So let's have a look at the guard decorator. So the guard decorator is going to protect the decorator child from running if another guard of the same token is already guarding or running. So let's have a look at an example for this. So let's say we're using a parallel composite. Set that to start. And what I'm going to do is I'm going to grab a selector and another one over here. So it's going to run these 2 selectors in parallel. And I'm going to grab my seek and I'm going to grab my patrol points. Okay, I'm going to plug those in like that. So I'm going to make an action and assign a debug log. Let's call this log1. Copy paste that. Log2. And in fact, just for the sake of it, let's copy paste this. Okay, let's set this up to be log3. All right, so now if we play it right now, it's just going to run all of these 3, right? So let's have a look. it's going to run the seek player, the patrol points, and the flee from player at the same time, which does not really work. It's really not clear to us which one is running, which one should be running, and in general, pathfinding in parallel should not be supported. So what can we do? We can add a guard. So right-click, decorate, and I'm going to add a guard decorator like that. So what we can do is we can create a new token, graph create new, go to the graph, there it is, and I'll just call this pathfind guard token like that. And then I'll just copy paste that and decorate the other pathfind operations we have like that. So now when I play, only one of these is going to be selected. So you see only the seek one is selected, and he's just going to continue to seek because we're guarding, and these ones are blocking it from progressing. Now, what I can do is I can now change these to be random. So it'll randomly choose between a log or a pathfind operation. Now, you see it actually logged these ones because these failed, because the token was already claimed by this operation. So now if I play, see it randomly chose to do the patrol points. Now it randomly chose to pursue me. And even though all of these are randomly choosing at the same time, because we have a guard, we can safely limit it to one operation and we can see which one he's doing here. And this is really useful, especially when your graph gets a lot bigger and you have certain things you want to do, but you don't know if another branch is actually doing that or not. All right, so that's an overview of all the different decorators that you have access to with behavior trees in NodeCanvas. You can make some very powerful AI behavior with all of these. So hopefully you can use this knowledge and make some really exciting behavior for your enemies or anything else in your game.